Welcome back to Crash Course 2.0. Today we'll be taking a look at stoichiometry, which derives its meaning from the Greek words stoichion, meaning element, and metron, meaning measure.
In stoichiometry, we have to find the mass and sometimes volume of certain products involved when using a chemical equation. Just like any chemical equation, the amount of supplies affects the amount of products.
For example, a car requires a chassis, an engine, and a steering wheel to operate properly.
And in the same way, the reactants of a chemical equation determines how many products there are.
In a nutshell, stoichiometry is the process of understanding how much of one element is created with the size of another one. Most cars run on gasoline.
The chemical equation for gasoline goes as follows.
Say we're mechanics and we have 6 moles of octane gas and 3 moles of oxygen gas, and we're curious how much octane gas would be left over after the reaction occurs.
This is important information to have because it shows us how much excess gas goes into the atmosphere and pollutes it.
First, we need to find what our limiting reactant is. We find that it is oxygen by multiplying our 6 moles of octane by our 25 moles of oxygen, and we get 25 from our chemical equation. Next, we divide by our 2 moles of octane, which we also get from the equation.
Once we have found our limiting reactant, we use that and multiply 3 moles of oxygen gas by 6 moles of octane gas and divide by 25 moles of oxygen gas. Once we have done this, we know how much octane is used, so we subtract the amount we are given by the amount we use, and we finally find how much octane is released into the air.
Octane gas reacts with nitrogen oxides in the presence of sunlight to form ground-level ozone, a primary ingredient in smog. Though beneficial in the upper atmosphere, at the ground level this irritates the respiratory system, causing coughing, choking, and reduced lung capacity.
Car manufacturers use this information to make sure that their cars are safe for the environment and as efficient as possible.
To help you understand this better, we'll go back to the topic of cars.
If we only have 30 steering wheels, 30 engines, and 15 chassis, we would only be able to make 15 cars due to the limiting property of the chassis, but we would still have 15 steering wheels and 15 engines that are left over. Thank you for tuning in to Crash Course 2.0. If you like this video, slap a like down below.
And check out our other videos right here.
And check out our t-shirts right here.
See you next time on Crash Course 2.0.